In this video, we can see about Tesla Coil. The Tesla Coil is a resonant transformer designed by the great scientist Nikola Tesla. It produces high voltage at high frequency and low current. The Wardenclyffe tower, designed by Nikola Tesla for the wireless power transmission, is also based on the same technique as Tesla Coil. Here we have used the simplest Tesla coil circuit, which is known as Slayer exciter. Let's see how the circuit works. Here we have used the 2N222A transistor, which is an NPN transistor. It is not necessary to use the same transistor, but we can use some other NPN transistors. Initially the switch is open, hence no current flows through the circuit. When the switch is closed, the current flows through this wire, and at this point the current gets divided into two, I1 and I2. The current I1 reaches the base of the transistor through the resistor, and the current I2 reaches the collector of the transistor through the primary coil. This is an NPN transistor which conducts when the base is positive. Here the base is positive and the current flows through the transistor and closes the circuit. By electromagnetism, a current carrying conductor produces a magnetic field around it. The magnetic field produced around the primary coil gets linked with the secondary coil due to mutual induction, which in turn induces an EMF in the secondary coil. By Lenz's law, the induced EMF opposes the change or cause that produces it. Here the cause that produces the EMF in the secondary coil is the current through the primary coil. Hence the EMF in the secondary coil opposes the current in the primary coil. Hence the lower end of the secondary coil becomes negative and the upper end of the secondary coil becomes positive. The lower end of the secondary coil is connected to the base of the transistor. Now the lower end is at negative potential, which causes the transistor to turn off. When the transistor turns off, the magnetic field in the primary coil reduces slowly. Now the secondary coil opposes the reduction in magnetic field in the primary coil. Hence the lower terminal of the secondary coil becomes positive and the upper terminal becomes negative, which causes the transistor to turn on again. This cycle repeats and this process happens thousands of times per second. This is how the high frequency gets produced. I measured the frequency using my multimeter and it shows nearly 8 MHz. The high voltage is due to the turns ratio of the primary and the secondary coils. By transformer equation, if the primary coil has 3 turns and the secondary coil has 300 turns, then the voltage through the secondary coil is 100 times the voltage through the primary. Now let's see how the fluorescent bulb glows when it is bought near the Tesla coil. Though the upper terminal of the secondary coil is open, there is a capacitance formed between that terminal and the ground, which excites the ions in the fluorescent bulb. Now we can see how to troubleshoot the Slayer exciter circuit. Use a standard size tube and number of turns. Previously I used a thin tube with a large number of turns, which failed to work. Sand the tips of the primary and the secondary coil. The copper coil is enameled, hence remove the coating at the tip before using. Don't use a power source with huge voltage rating, which may burn the transistor. Similarly, don't use a low voltage power source. Check the transistor before using.